All right, today we're going to go over transformations of radicals. And in order to do that, I want to go ahead and refresh your memory on those parent functions that we talked about at the beginning of the year. So the function this time is the square root. So this is y equals the square root of x. That's going to be our parent function that we work with. We'll get started by showing you that on the calculator. Go somewhere where there's not a glare, sorry about that. And so here we want to hit second and then the x squared key, and that gives us the square root. It is going to stay under the square root until you use the arrow key to get out. So if there's something you want to put outside of the square root, make sure you're using your arrow key to get out of it. But for the parent function, we just need that x under the square root. Now when I hit graph, here is our graph. There we go, sorry about that, trying to get somewhere where you don't have a glare. So we see that it starts right here at the origin and then it goes up and to the right forever. We do not have anything on the negative side here. We don't have anything below the x-axis either. It is starting right there at the origin and going to the right. So let's look at what the table looks like there. So if I go to my table, I see that the negative values say error. And then it goes to 0, 0, and then we've got 1, 1, and then there's some decimal values until it gets to this 4, 2. That's because the square root is looking for those perfect squares. So our key points are going to be from those perfect squares. There are decimals there, but those aren't very easy to graph, so we're not going to focus on those. Again, the negative values say error. If you're using Desmos, it says undefined, but it's because when we take the square root of something, we get an imaginary number, so that we don't want to focus on those on graphing. Now, the square root of 0 is 0. The square root of 1 is 1. The square root of 2 is 1.41, and again, we wouldn't want to focus on that, and the square root of 4 is 2, and the square root of 9 is 3. So I'm going to go ahead and put those on my paper here so we can see that. So 0, 0, 1, 1, 4, 2, and 9, 3. And there is my graph. Again, those are the perfect squares are the ones that I just graphed there to get that. There's nothing on the negative side and there's nothing below here. So I'll go ahead and write my domain and range for this. It is starting at 0 and moving forever to the right. So that would be 0 to infinity. And I do want to have a bracket here because it's including that 0. For our range, it starts at 0 and goes up forever. And again, I'm including that because we do have a point at 0 on the y. So 0 and 0 are both on the x and y. Those are our beginning points, so we want to have a bracket there. This right here would be the minimum value. It's the smallest point on the entire graph, and then it goes up forever, so there's no maximum. And this graph is increasing the entire time. I'll go ahead and refresh your memory as well on the y equals cube root of x. We talked about this one a little bit already. We would be looking for our perfect cubes here. And so this cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So those are my perfect cubes. Those are the ones I'd want to focus on in graphing. If you did the cube root of 4, you would get 1.59. Again, you don't want to focus on those when you're graphing. So I'll go ahead and put that on my paper here. If you went to the negative side, the cube root of -8 is -2, so you can have that side as well. Remember, this is the inverse of a cubic function. So the graph looks like the inverse of a cubic function. There's our two graphs that we'll focus on this radical section. This one does have a domain and range of all real numbers. So it's a little bit easier on that graph. Now, before we can get started on graphing these, we want to go ahead and review transformations. Remember, transformations are the same on every single function we deal with all year. So the only thing that's changing is the operation. In this case, the square root. That's our operation on this function. So that's the only thing that's changing. That A, B, C, and D are doing exactly the same thing they've done for all of the functions we've dealt with all year. But we'll go ahead and review those before we get started. So when our A value is between 0 and 1, that is a vertical compression by the A value. That means we're going to take our Y values from our parent function and multiply them times A. If our A value is bigger than 1, it is a vertical stretch by A. So for vertical compression, you're squeezing in from the top. vertical stretch, you're taking it from the bottom and pulling up and down. And then the last one, if the A value is negative, it is a reflection across the X. All right, B is the harder one. That's the one that's inside of the operation. And notice it must be factored out before you start determining those transformations. It must be in this form and nothing should be in front of the X. It should be factored out before you make those decisions. All right, so if our B value is between 0 and 1, it's the opposite of that vertical. So it is a horizontal stretch by 1 over B. So our scale factor flips. That means if there was a 2 here, your scale factor would be 1/2. And it is a horizontal stretch, which means we took it from the side here and we pulled this way. That's what a horizontal stretch is. You're taking and you're pulling it horizontally. And which means we're multiplying our X values by this 1 over B. For our B value being greater than 1, that is a horizontal compression by 1 over B. Again, we flip whatever number is right here for that scale factor, and a horizontal compression, you're taking it from the sides and squeezing it. And then the last one, if our B value is negative, it is a reflection across the Y. A lot of the functions we've dealt with this year, there's no big difference when you're reflecting across the Y. This is definitely one that you're going to see. A reflection across the X-axis would bring it downward like this. A reflection across the Y-axis would bring it over to that second quadrant. So there is a difference in this function from its parent function. All right, C and D are usually the ones that students got pretty quickly, so they know these well. So X minus C goes to the right. X plus C goes to the left. And then plus D is up and minus D is down. Those are the ones most students get at this point in the year where we've gone over so many different functions. These are the ones that are a little bit harder. We'll start by talking about the transformations, looking at those equations. So when you're looking at the equations like this, you should be able to tell what the transformations are by looking at what place it's in. Notice that it is factored, so it must be in that form before you start talking about those transformations. All of these are. So this would have 3 different transformations from the parent function. The first one is this 4. It is inside of this operation. It's inside of that square root. So that makes it the B value. Now we said that when the B value is greater than 1, which 4 is greater than 1, it is a horizontal compression by 1 over B, which would be 1 over 4. So this is a horizontal compression by 1/4. For the part here, X plus 1, we said if it's X plus C, it would go left C units. So this is to the left 1. And then this last one, the plus 2, is that D value, so this would go up 2 units. And that's how we would graph from the parent function. So we'll do a couple more of these. We've got a negative here. That would be a reflection across X because it is on the outside. This right here would be a reflection across the Y because it's on the inside. So it's important you look at where it is. So on the outside, reflection across the X-axis. On the inside, reflection across the Y-axis. This right here would be down 2, and this part would be right 3. So that's one of the easier things, is to look at those transformations and be able to tell what transformations occurred. All right, so on the bottom here, we're going to talk about one that's going from the parent function, and it gives you the transformation. So you want to be able to do that as well. The cube root function has horizontally compressed by 1/3, shifted down 3, and reflected across the y-axis. So the first thing I notice is what parent function it gives me. That tells me which operation to use. So I know the cube root here, horizontally compressed by 1/3. We know that when we say horizontally compressed by 1/3, this is 1 over b. So what I'm going to put on the inside here is that 3, because the b part is that 3. I'm shifted down 3 units is going to go at the end here. That's what that d does. And reflected across the y, I need that negative on the inside. So that would be my equation there, coming from its transformations. Now we're going to look at graphing one. So first things first, always get it into that correct transformational form. Don't start saying what transformations they are until you get it into that form. So here I would want to factor out a negative. Negative times x gives me negative x, and negative times a negative 4 would give me that positive 4. Now the plus 2 is on the outside, so we're not touching that one. So this has 3 transformations. It's got a reflection across x because, across y-axis because that's on the inside. So this is a reflection across the y. Then it's going to the right 4 because it's got that x minus 4, and it's going up 2 because it's got that plus 2. So we start with these parent function points that we have right here, and we apply these transformations. Reflections and stretches and compressions always come first. Then you do the translations right, left, and up, down. So we would start at this 0, 0 point. I can't reflect that across the y because it is on the y. I can move it to the right 4 and up 2, so that would be right there. My next point, which is at 1, 1, I reflect that across the y. So it would come over here to negative 1, 1. I then move it to the right 4 and up 2. That gives me the next point. I can continue to do that with every single point, or you can think about that parent function. It goes over 1 and up 1. This is going to the left 1 and up 1 because of the reflection. The next point would go over 4 and up 2, so I can go over 4 and up 2 to get that same shape. And so there is my graph. This does change the domain because notice all of these values are coming from the negative up to 4. 4 is my biggest x value. So my domain would be from negative infinity to positive 4. And it would have a bracket there because we do have an x value at 4. Now we look at our y values, and the smallest y value is 2. So it's going to start at 2. There is a y value there, so I'm going to have a bracket, and it goes up forever, so this goes to infinity. This right here would be my minimum point on this graph, and then it goes up forever. So there's no max. All right, we're going to look at another one here, number 3. We're going to write the equation for this one and then graph it. So it says, write the equation of a square root function that has been reflected over the x-axis, shifted right 1 and down 3. So this is a square root one, so that's the operation I'm going to do. To get it to reflect across the x-axis, I need a negative in the front. To move it to the right 1, I'm going to have that minus 1, and then to move it down 3, I'm going to have the minus 3 at the end. All right, so to graph it, again, we start at the 0, 0. It can't reflect across the x-axis because it's on the x-axis, but it can go to the right 1 and down 3. The next point, which is at 1, 1, I reflect that across the x-axis and it comes down here. I move it to the right 1 and down 3, and here is my next point. Notice it's below. That's because of that reflection across the x-axis. And just like we did the other one, now we know it's going this way, so we can go 4 and 2 like the parent function. And we get a graph that looks like this. Of course, you can always use your calculator to do it, but that's what the great part of transformations is, that you can graph without a calculator. It starts at 1 right here for my domain, and it goes to the right forever. So we would have a 1 to infinity. And again, we would have that bracket because we are including that 1 point. For our range, it is coming from the bottom, so we're going to start at negative infinity, and the biggest y value is right here at negative 3. And there is a point there, so you're going to have a bracket in order to show that that point is on my graph. That's the biggest y value there. Notice that those points are showing from these 2 points right here. -3 is that one right there, and that -1 is this point right here. Or sorry, the +1, because that's the C value. That's my vertex. If you haven't recognized that, 1, -3, that's my CD. CD are my vertex. 1 and then -3. Notice on the one that we did up here, my C and my D was 4 and 2. That's my vertex right there at 4, 2. So your vertex is that C and D value when you're graphing. All right, the last thing we want to talk about here is that minimum and maximum value, just so that we can practice that. When you're answering that question on a quiz or a test, or on anything for that matter, you really want to sketch a picture so you can know what's going on. So it says, what are the minimum and maximum values for this graph right here? We've got a reflection across the X, left 3 and down 2. So I would want to sketch a picture. Left 3, down 2, and a reflection across the x-axis looks like this. So looking at this graph, I have a maximum. I do not have a minimum because it keeps going forever. And when it talks about the value of a function, it's talking about the y. So our y here, we said that vertex is going to be that part right there. So the vertex would be -3, -2. That's the CD. But the value is the y. So the max here would be -2. And the min would be none because it goes down forever. So it does not have a minimum. All right, for what are the minimum and maximum values of this one? We've got a right 1 and up 2. So right 1, up 2. This one has no reflection, so it's going to go in the same direction as our parent function. The vertex for this one here would be 1, 2, because that's our CD value. And this is a minimum. So the minimum here would be 2. Our maximum would be none because it goes up forever. So there is the min and max information on this graph. The radical is usually a good function to practice all of these transformations on because it's an easier one to work with. Students usually prefer it over some of the other functions we've done in Algebra 2. Our transformations, again, work the same as all the other ones with the A, B, C, and D, and hopefully you've got those down at this point. But there's our transformations with radicals.